Good morning, everyone. So, welcome to another MGC class. I see I've had a couple of questions regarding the practical zero. So, Prac Zero is basically just an assignment that we created for you to not specifically do the drawing, but do the submission part of the assignment to make sure that you understand how the AMS system works. So, you're welcome to go have a look at the assignment. It is under the practical assignments and its name is practical 0. It's practical 0 because it's not yet practical 1. So as I said, just so that you can practice and make sure you understand how to submit something on the AMS online system. It will be marked, I think, but it won't count anything. Okay, so are there any questions on that stuff before we start with today's class? Do you have to use the drawing block paper? I think it's always a good idea. For this time, you don't have to bother, but from the next one onwards, yes, you have to use the UP paper with a drawing block on it. Doesn't have to be printed, you can draw it by hand as well. Now you must submit it onto the AMS system. So please don't submit it on ClickUp because it won't be marked if it is on ClickUp. You can draw it on any size paper you want to, but just remember that there are practical limitations to A4 compared to A3. Okay, so for the AMS system, if you use paper with lines on it, it is okay, not really a big deal. So don't worry too much. If that's all you can get, then use that. It's not the end of the world. So the AMS system, you simply go to ams.up.ac.za. I think Mr. Setsedi did make a video on how to do that. Okay, so let's start with today's class. The other stuff you should be able to find after the class in any way. I think drawing on an iPad with an Apple Pencil, I don't know what it would look like. You can try it, but you're most likely going to not be able to draw or make drawings of the same quality as what you would if you do it by hand. Okay, good. So let's start with orthographic classes. Just want to quickly see what the question was. Oh, it's a pleasure for the drawing the 3D blocks. That was kind of why I made it. So, orthographic drawings. Ortho means perpendicular, so orthographic drawings are basically a number of drawings which are one is perpendicular to the one adjacent to it. It's also known as multi-view projection. So we had isometric, which was a single view, like a 3D view of the object. Orthographic is multiple 2D views. Now, multiple 2D views is usually just a bit easier and more accurate to place sizes onto. The sizes are called dimensions. So it's easier to place a dimension onto something where you actually look straight at it, compared to the 3D pictures where you'll have different planes of dimensions over each other, which is just way too confusing. So basically, lecture 4 for each of the 3 groups is going to be the same session. So G3L4 and G1L4, that was yesterday's class and today's class, are doing the same content, just not on the same day. People from G3 or G1 are allowed to be here, so I don't mind if they jump from one class to the other one. Doesn't really make a difference to me. Okay, so basically we have a view of a component, and then to the right of that we place the right hand view, to the top of that we place the top view. This is just a screen showing more or less that you just draw what you see. So this camera would just see the L shape of that blue block, and then for the frontal view it would just be the L shape. If you view it from the right hand side, you'll see the little rectangle at the bottom and the rectangle in the background. So that's why we've got the two rectangles there, and from the top we'll see that rectangle and that one, which will give you the two rectangles. I'm going to do a couple of examples, so don't worry too much about that right now. This is Buzz. He is located at infinity. And the reason why we say it's an observer at infinity is to let the effect of perspective kind of diminish. So the fact that the back edge is further away than the front edge doesn't really make a difference in orthographic drawing. So that's why we assume that the observer is standing very, very far away. And then we just fold it open to place the views. I'm going to explain all of these red text things in detail in a couple of minutes, so don't worry too much about that. I did make an isometric to orthographic explanation with the little block that I used in isometric classes, so I'm assuming most of you guys have gone and viewed this video as well. Okay, so now we're going to start with the main view. Now, selecting the main view is actually quite important because, as we showed before, all the other views are actually projected from our main or front view. So we have some criteria that we can use to find the main view. The first one is a natural orientation. So natural orientation just basically means you'll put something in the orientation that it would normally function in, rather than just putting it in the orientation where it fits on the page the best. So main view is decided based on natural orientation, and then probably at the same level of importance is the view that is the most descriptive of the profile. So usually the one with the longest base length. I'm just quickly going to open my camera app. I heard a comment coming through. Haha, yes, not your cam. It's your cam. Well played. Yeah, it's actually a free little program and it works very well. It's YAW because it's yet another webcam software package. Okay, so here we have the little car that is also in the slides. Now, let's assume the ground is here at the bottom. So, if it was a Volkswagen Beetle, this would be a potential natural orientation. but this is a sport beetle, so it's a Porsche, meaning natural orientation with the wheels at the bottom. So that means this could be a main view, or something like that could be a main view. So the first criteria is natural orientation, meaning wheels on the ground. So the second criteria is the view with the longest base length is my main view. So I've got this view, or I have that view, and I must choose which one to use as my main view. Now let me quickly show you why it's important to choose the longest one as your main view. I think that's a bit close. Let's go a bit further out. So if we have a main view like this, then a top view of this main view will be something like that. Okay, so my top view is still long. And if I have my main view like that and the top view above it, you'll notice that this layout works well with a paper that is in landscape format. So if I had chosen this one as my main view, then my top view would be that one, which doesn't fit very well on a paper that is horizontally arranged or in landscape. So that's why the longest one, also showing the profile the best, is chosen as my main view, because then that would automatically make my top view fit in nicely on the page. Yes, I inherited this Porsche from my wife's dad. Okay, so natural orientation and most descriptive of the shape. And longest base length is very handy because that then allows the top view to also fit in on the landscape paper. Let me show you an example of that. This is not a yawning rabbit, it is actually a stapler. So if I chose my main view over here, then my top view would be a very long top view, which is a very bad use of my real estate that I have available. So if I chose this longest view for my main view, then the top view would fit much better on a landscape paper. So then we have the drawing plan. So as I just discussed with you guys, first thing to do is to choose your main view. So please remember the main view isn't always located on the bottom left of the paper. It depends on what details you need to show in your sketch. For example, you could have a main view at the top and a bottom view of whatever component. It depends on what you need to show. If you specifically wanted to show exhaust pipe layout or something on this example, then a bottom view would be important and a top view wouldn't. So then we'll have a main view and a bottom view. Okay, so it really depends on what you need to show. So then after you've chosen your main view, you start by constructing a box that outlines the basic shape of the view. Usually we leave about 40 millimeters between the views for dimensions. So dimensions are just sizes that we'll add in a week or two's time. Then you can start with the outside lines, and after that you can show the internal details. Then you darken the visible edges, add hidden detail, add center lines, and after that you can add your dimensions. Will you be doing these drawings with tools? Well, if by tool you are referring to a pencil, then yes. So yes, it is still freehand drawing. Everything in MGC is freehand. The reasoning is it um, it doesn't make your drawing more or less correct to draw it with a ruler. It just makes it take longer or shorter. Shorter being without a ruler. Okay. Please note that dimensions must be consistent in all views. The right view, for example, cannot be drawn with a height different from the main view or a depth different from that in the top view. You will probably not lose marks directly if you use a ruler, but you will lose marks if you take so long that you don't finish the drawing. Okay, so consistency for dimensions, let's quickly have a look at that. Here I have a aerosol bottle cap. So in the one view, it is a circle. Okay, so there we have a circle, or an attempt at a circle. If I view this cap from the right-hand side, then I turn it like that. So a right-hand view of a cylinder, if I see the circle in this view, then in the right-hand view, I will just see a rectangle. Okay, so there's the rectangle. If I view this view from the left-hand side, I will see the circle. Okay, so it's important to note a cylinder is a circle from one side. If I view it from the right-hand side, it is a rectangle. If I view the circle from the bottom, it is still a rectangle. Okay, here we have another cylindrical object. From that side, it is a circle again. Okay, so there we've got the button on the top, a little ridge, and then the rest. So from this side, it is a circle. From the right-hand side, now it's important to note, if I view this thing from the right-hand side, then this button, if I view it from the right, the button will be on the left. Okay, so there the button is on the left-hand side. Okay, so that was important to note. If the button is closest to me in the main view, if I view it from the right-hand side, then the button is on the left-hand side. So the button is on the left-hand side. Last quick one is just my little level box. In this view, it is a square. So there it is, a square. we want, we can add the 4 buttons. So that we have the 4 buttons. So if I view this thing from the right hand side, the buttons will be on the left hand side. Now what's important to note is this block, or my level box, hasn't become taller or shorter if I turned it. Okay, you can see the total height is still the same. So if I do a right hand view, this right hand view isn't taller or shorter than the main view. They are still the same height. So that's quite important. As you turn something, objects must still be in line with where they were. So the ground didn't shift if I move from this view to that view. It didn't suddenly move somewhere else. I just want to quickly check the questions. So there will be classes where we have to draw the bottom view of an object. Yes, it depends on what the question asks you to do. But yes, there will definitely be cases where we're going to draw a bottom view. Okay, so I didn't specifically choose any of the two. This was just an example of how to turn the view. So the longest one would be the main view. So of the battery example, the side view of the battery would be a main view. So in this case, we just had a main view and a left-hand view. Well, you say that's why you need a ruler, so the object can be the same length. But if you watched what I had just drawn, then they were close enough. We'll only start giving or deducting marks if you have massive differences or obvious differences in height. If you have any small difference at the top there, obviously it's freehand drawing. We can't be too fussy on that. Okay, let's continue. So basically what this slide says is if it's a certain height in the main view, it must also have that same height. Yes, the battery and the cap example, the bottom and the side views are the same. Okay, so choose the main view, then draw the blocks with about a 40mm gap between them on an A3 paper. So if you're doing it on A4, remember to make that size smaller. Then start to sketch the details by using construction lines for the internal stuff. I'll explain this in a moment. Darken the visible edges, erase construction lines, and add hidden detail and center lines. Now something that's interesting is you can use a line at 45 degrees to be able to project information from your right-hand view to your top view, or from the top view to the right-hand view. I'll show this to you in an example in a couple of minutes. Well, I'm not sure what Tim is. but yes, freehand throughout the whole of MGC. Construction lines are in the thinner pencil, yes. Okay, so this is just an example of how to go from your views. If you have two views, how to construct the third one based on the information from these two. For MGC's purposes, we're always going to erase our construction lines. So if I want to draw the right-hand view of this cylinder with an inclined top plane, I can construct it based on the top view and the main view. So what I do is I use that 45-degree line, that one, to transfer information over from one view to the other one. So if you want to draw a right-hand view of this inclined plane, remember, with it being freehand drawing, we're just following these steps in our head to plot out what it should look like. We don't really have to draw it very, very accurately. So what I'm going to do is I'm going to divide this circle into a number of points and then transfer those points over to get my oval or ellipse, and then I'll just use a freehand line through all those points. The 45-degree line should line up with the bottom of the top view and the left side of the right view. So that's where we draw the line at 45 degrees. Then the right-hand side will line up with the furthest point on the top view. And there I've randomly divided it into 8 equal parts. You can just divide it into 4 if you really want to. The more points you use, the finer the resolution would be. So point number 2, I project that over to my 45-degree line. Where it touches that line, I go down. And I also, from the top view, go down to where it reaches my inclined plane, and then I go to the right-hand side. Now, where those two lines intersect each other, that point there is where point 2 would lie in my right-hand view. So I can follow those steps for each of the points, and then I have a whole bunch of points, and I can just use a freehand line to complete that view. So as it says here, it's freehand drawing. These steps are just followed in your head. We're not going to be drawing this very accurately, although it is a handy method to get a good idea what the side view should look like if you have a top and a main view. Well, it depends on which views you have to make. The 45-degree line works at the top right in this case, but if you're doing a left-hand view, then your view layout would look different. So it's not a guarantee that you can always do the top main right with a 45-degree line at the top right. Yes, if you did EGD at school and you want to use those methods, you are allowed to do that. I'm not going to put any limitations on you for that. Okay, so as I mentioned earlier, your views should be in line with each other. So that view isn't in line with anything in any of the other views. The same with this one. Now, the whole idea of orthographic drawing is that if you draw your views in line with each other, then you can easily relate features of one view to their location in the other view. For example, here on the top right, the bottoms line up. So the center of the circle should be that center line over there. So then I can use the center line in my right-hand view to show me where this cylinder lies. So that's why it's important for them to line up correctly. And because we're drawing in third angle projection, the right-hand view of the front should be on the right-hand side. The top view should be at the top, the bottom view should be at the bottom. Meaning, if I have my right view on the left-hand side, this is first angle. So we're not drawing in first angle. Well, technically the line doesn't have to be exactly 45 degrees, but if it's far off, then the right view and the top view won't perfectly line up with each other anymore. So you can estimate it, I do agree. Remember, it is freehand drawing, so we're not going to hold you accountable for the nearest half a millimeter in your drawings. So in MGC, we will always draw in third angle. Now, you don't have to draw the 45-degree line. It is only if you want to convey information over from one view to the other one. Yes, tomorrow, Thursday, is a Monday timetable. So the curved cylinder thing is basically you transfer the points over and then you just draw a freehand curve through the points. Okay, so let's quickly do an example together. So this is an isometric view of a component, and we are now supposed to draw it orthographically. Okay, so no problem if you didn't do EGD at school. Remember, probably I would guess about half of our class, half of the MGC group didn't have EGD at school. So it's not a problem at all if you didn't have it. That's why we take you up from the basics all the way to the top. This is a 50-minute long session. Your assignment is not due on Friday, it's due on Thursday. So the question about first and third angle, the one isn't more right than the other one. They are just two conventions used for projecting your views. And it's basically just a rule that says if a view is in a certain orientation to a different view, what am I showing in that view? We use third angle because it is more intuitive, but first angle is also not incorrect. One must just then at the bottom of your page always indicate whether you're drawing first angle or third angle. Yes, the assignment for tomorrow is practical 0. Okay, so let's quickly do this example. So now we need to make an orthographic drawing of this component. And first thing to do when we want to make an orthographic drawing is choose our main view. So this view here from the bottom left has a length of 1, 2, 3, 4, 5 blocks. It is 1, 2, 3, 4 blocks high. The view here from the bottom right is 1, 2, 3, 4 blocks wide. 1, 2, 3, 4 blocks high. So the longer one of these two is this one here from the bottom left. It is 5 by 4. This one here from the bottom right is 4 by 4. So I'll have a main view, a right-hand view, and I'll also include a top view. So let's start by drawing the boxes that should contain each of these views. Okay, so just to quickly answer this question on the difference between first and third angle. First angle says what you see from the right, you draw on the left. Third angle, which is the one that we use, and in my opinion is slightly more intuitive, is the one that says what you see from the right, you draw on the right. Okay, so there's my battery again. So if we draw that view, so first angle says what we see from the right, we draw on the left. So first angle would be okay, so first angle would be what we see from the right hand side. We will draw on the left hand side. So this is first angle. Third angle says what you see from the right, you draw on the right. So that would be third angle. Okay, so the number of blocks, you simply just count them as was shown. There is no second angle. I don't know why they skipped second angle. You can draw the practical on any paper, yes. So this one, to see the width, basically what I'm doing is, let's count the entire distance in this direction. So there we have 1 block, 2, 3, 4, 5 blocks. So this view here from the bottom left is 5 blocks long and 4 blocks high. Tomorrow's practical doesn't count, so technically you don't need anything. But a title block is a good idea for you to practice on. Okay, let's start with this example. Okay, I'm just going to zoom in a little bit. Feels like the start of Aladdin. Ah, my friend, come closer. Ooh, too close. Right, so we have a main view, which is 5 by 4. A right-hand view that's 4 by 4. And a top view that's also 5 by 4. Like that. I'm glad you caught the reference to Aladdin. Okay, so there was an animation movie long ago called Aladdin, and it started off with the scene of a guy that said, "Oh, my friend, come closer," and then the camera ran into his face. So when I was zooming in on this camera of mine, I over zoomed, and then it made me think of the Aladdin movie. Okay, so here at the bottom left, as we approach this block, the first thing we meet is a rectangle that is 1, 2, 3 blocks wide and 2 blocks high. So over here, we have the rectangle that is 3 blocks wide, 2 blocks high. As we go slightly to the back of that, we have this inclined plane over there. It is 1 block wide, and seen from this side, it looks like it's got a height of 2 blocks. 1 block, 2 blocks. So there we have that inclined plane. It is actually pointing into the page. So in my right hand view, it would be something like that. If I look at it from the left hand side, it looks like it is 1 block wide, 2 blocks high. To the back of that, I have this skew block over there, which looks like it is 2 blocks wide and 2 blocks high. 2 blocks wide, 2 blocks high. Right hand view. As I approach from the furthest side, the first thing I meet is this block that is 1 wide and 2 high at the bottom right hand side. So over here, it is 1 wide, 2 high. Slightly to the back of that, I've got this skew rectangle over here, which is 1, 2, 3 blocks wide from this side, and it's 2 blocks high. So it's 3 blocks wide and 2 blocks high. Then further to the background, I meet this shape over there, which on the right hand side is 2 blocks high and 2 blocks wide, and then from there it goes down to the bottom left. So here it is 2 blocks high and 2 blocks wide, and from there it goes down to that side there. Now from the top, as I approach this thing from the top, the first thing I meet is that little rectangle there. It is 1 wide, 2 high, located in the top left of my top view. So over there, 1 wide, 2 blocks high. Slightly beneath that, I've got this inclined rectangle there, 1 block wide, 2 blocks long. So it's over there, 1 block wide, 2 blocks long. Then beneath that, I've got this shape over here, which is 1, 2, 3, 4 blocks on the top and 2 blocks at the bottom. Something like that. So now I have done the basic lines for these views. Now I can use my thicker pencil to darken all the visible edges. I'm going to come back to this now. I just want to quickly check the questions. I'm assuming that is a link to the video. I'll check it afterwards. Maybe it's dodgy and then I'll get into trouble. Okay, so I'll leave this on there for another couple of seconds for you to finish drawing that view, so that we can go on to the last one, which is slightly more tricky than this one we just did. And remember also that you can now erase your construction lines. Okay, another 20 seconds. Oh, okay, that's funny. Yes, we're going to do center lines in the next question. Okay, I'm glad it's just that scene. I was figuring it was. Okay, next question. Orthographic example 2. So again, we must first start by finding or deciding on our main view. So this one has a length 1, 2, 3, 4, 5, 6 blocks here from the bottom left, height of 4 blocks. From the right hand side, it is 4 blocks by 4 blocks, same as the previous one. So in this case, this view from this side is going to be my main view again. So let's quickly do that. Okay, 6 blocks by 4 blocks. 4 blocks by 4 blocks. Top is 6 by 4. Okay, as we approach this main view from far away, the first things we make contact with are these two rectangles, which are 1 block high, 2 blocks long each. Okay, 2 rectangles, 1 high, 2 long each. Second thing we meet as we go a little bit deeper is that square, which is 2 by 2. That 2 by 2 square. Slightly more to the background is this arc with the circle in it. Something like that. From the right hand side, the first thing we meet is this cylinder, which is 2 blocks long, 4 blocks high. Remember, as I showed earlier, a cylinder from the side is just a rectangle. And then in the background, if we move further back, we meet that shape over there. Something like that. And then from the top, as we come down, we have this L shape over here. So at the top, it's just the flat, and then it smoothly goes into the cylinder at that point there. So the top will look something like that. Now I'm quickly going to darken my visible edges. something like that. Yes, I'm going to do the center lines now, and I'm going to do the hidden detail now as well. Okay, so next I'm going to show the hidden detail. So from the top, this edge will make hidden detail over there. Okay, so there's the hidden detail for my top. I want to show the center line for the circle in my top view. So there's the center line in my main view. There's the center line in the top view. There's the center line in the right-hand view. And last thing is the hidden detail for this cylinder. It can either be shown in the right-hand or the top view. Seeing as I've already showed hidden detail in the top, I'm going to put this one in the right-hand view. We're going to discuss in the next class why we only show hidden detail once. And there we go. Yes, you can change the darkness of the lines by changing the how hard you press as well. Yes, we are going to erase all our construction lines in MGC. Basically, yes, same answer. Hidden details will count for marks later on, yes. We only show hidden detail if it is necessary. Okay, I'll do the ISO and ortho in a moment. Yes, we don't show hidden detail on isometric drawings. I think it might just be the resolution of the camera that causes some of them to look like dots and some of them to look like lines. So there's the isometric again. This 2x2 rectangle from the top will cause the hidden detail line over there. And that cylinder will cause the hidden detail on the right hand side in the right hand view. So there's the hidden detail for this rectangle over there, visible in the top view. And that hidden detail is for the cylinder in the right hand view. So you show hidden detail if it is important to the drawing, that you are actually able to dimension everything on the drawing. No marks for construction lines, no. We're doing everything in third angle. Okay, I'm just going to put this one back. So I'll leave this answer here. This is basically then the end of the class. So I'll see you guys again tomorrow for our next class. I just want to quickly double check our daily timetable. So yes, we have lecture 5 tomorrow for you guys. This was actually enjoyable. You sound surprised. I think it's always a good idea if you can name the PDF file according to your student number. That makes life a lot easier for everybody. Okay. I'm sorry to hear that. That compared to other classes, this one was enjoyable. Yeah, shame. It's a massive jump from what you did last year to what we're doing this year. Yes, I'll go click the link after the session. I'm so glad to hear that mine aren't confusing. It's a pleasure. You guys must have a good day. I'll see you again tomorrow. No, we didn't skip a lecture. We're still going through everything. There is, according to my timetable, I kind of did 2 lectures in one, so I'll still figure that out. Okie dokie, people. Keep well. Sham, I'm glad to hear that.